All right, so this question came from a student, and so we're going to go over it. And I think it's a good question. I don't know if I have an example like this on my YouTube channel. So we're going to go over this one. And the first method that we're going to go over is the substitution method for solving quadratics. And yes, there are two different ways to do this. So that means I am going to be doing this a second time, but in a different method, okay? So I'm going to set this one aside here on the right, but I'm going to come back to it, and then we're going to solve that one just a little bit differently. But in the end, we're still going to use the quadratic because some of the solutions here are going to be, well, they're going to, once we get these to where we want them in a quadratic, they're not going to factor very well. So that's why it's going to be important to use the quadratic formula. Now, first up, using the substitution method, I can see that the first term is just an r, and then the second term has a square root of r. I don't really care about the -6, but between the r and the square root of r right there, essentially what we have is the first term and its variable being a square of the middle term's variable. And of course, they're the same base. So that means we're going to take, usually they'll use a u, right? They'll say u, and we'll make the u equal to the square root of r. And so if we were to square that, u squared, we would square the other side, the square root of r, which is just a regular r. Square root of r squared is just regular r because the square and the square root will undo each other. So that's kind of the work that I'm showing right there. So with this then, we can use substitution in the original equation. So in the original equation, r minus 6 square root of r minus 4 equals 0, we're going to take those r and the square root of r and replace them with the values that we now have for substitution. So that's going to be u squared minus 6r minus 4 equals 0, and this will now allow us to use the quadratic formula. We can see that -4, there are no two factors of -4 that will equal -6. So we're not going to get any very nice looking, pretty, rational type solutions out of this. So we will expect something irrational, which means we're going to go straight to the quadratic formula. So I've written out the quadratic formula down here, and then when we go into the quadratic formula, we're going to need those a, b, and c values. So we can see the a value is going to be 1, so a will equal 1. The b value here will be equal to -6, and then our c value is going to equal this -4 right there. So I'm going to go ahead and go into both parts of my quadratic formula. You can see I have -b plus, but also minus on this side, the square root of b squared minus 4 times a times c, all over 2a. So we're going to go ahead and go and replace those. The a is 1, the b's are -6, and the c is -4. Now remember, in this case, we are not solving for r yet. We are only solving for u. So when we put this into the calculator, we will have an answer for u, but not for r. So once we get that, we will have to actually do a little bit more work to find the r value. And when I put both of these into my calculator, these are the two answers that I got. Okay, now my calculator was actually showing square root of 13 plus 3, or negative square root of 13 plus 3. So, but either way, it's the same exact answer. I'm just showing it, kind of keeping this same format right here. We know that we got the square root of 52, which means you can factor out a 4, or simplify that square root with the square root of 4, which is 2. 2 times the square root of 13, so you end up with a 6, a 2, and a 2, which all can be simplified, and the 2 become phantom 1s, and 6 divided by 2 is 3. So that's what we end up with here for the two answers for u, not r. So this is kind of what we have right here, and if we wanted to kind of make this look a little bit better, would say this one is also a different value of u, and then what we have are two equations that we need to solve. But now I would go in and say, you know what, I don't really care to have the u's anymore. Let's put this in terms of the r. So we know instead of a u represents the square root of r. So we're going to put that one there, and we're going to put this one, the same, square root of r over here as well. Now, if I was looking at this with these two, let's just start here on the left. Square root of r equals 3 plus the square root of 13. What I would like to do right now to solve for my r is I would need to square that. Now, if I square one side, I know I'm going to need to square the other side. So really, what I end up with is this 3 plus the square root of 13 times itself, like this. But at least, right now, we see that that is going to equal just a regular r. So, what is that going to give us? Well, we can go ahead and start distributing now. So let's say 3 times 3 is 9. 3 times the square root of 13 is positive 3 times the square root of 13. And then also we have the same thing. Square root of 13 times 3 is going to be 3 times the square root of 13. And then our final distribution, square root of 13 times the square root of 13 is 13. So now this gives me, by combining like terms, I've got the 9 and the 13, which ends up being 22. And then I got my square root of 13 terms, which I have 3 plus 3 of those, which is going to be positive 6. So r, right now, ends up being 22 plus 6, whoops, forgot the square root of 13 right there, 6 of the square roots of 13. So that's one of our answers. Now, it may not be an answer, right? So we're going to have to go back and check up here to make sure that it actually works. But before we do that, let's go ahead and work on the 3 minus the square root of 13 there on the right. So again, same thing that we did on that last part. We'd have to take that square root of r and square it. But if we square one side, we need to make sure that we square the other side. So that's, we're going to get something that looks a little bit like this. 3 minus the square root of 13 times itself, and then of course the square and the square root are going to zero each other out. Now, without doing the distribution, we can kind of look at this as the square of a binomial right there. So we should end up with something like this. Let's see, 9, and then would have minus 6 times the square root of 13, and then plus that 13 there at the end. Of course, the 9 and the 13 still make up 22. So it ends up being 22 minus 6 times the square root of 13. And this would equal our other r value. So the last thing we're going to want to do here is just check these. Okay, so I'm going to check the first one in red. And let's go back up to our original equation. But again, I'll just keep working my way down right here. So this is what we got from the original, but now we're saying that instead of it showing as r, we're going to have 22 plus 6 times the square root of 13. So I've done that, and yet I had to move that minus 4 right there. Again, we are checking for truthfulness right here. So when I put this into my calculator, because that's all I'm going to do, and yes, it's okay to have a square root inside of this square root, this red square root inside of the black square root right there. But again, I'm just going to type this into my calculator, see what I get. And when I do that, again, I don't need to evaluate that myself. I'm just going to put that in the calculator. I get 0 equals 0, which I know is a true statement. Now, since I know that's true, I know that I have at least found this one solution of r that would make that true. But we need to do this with this second value that we found for r. All right, so there's our original equation. But again, we're going to take these r's and replace them with the 22 minus 6 times the square root of 13 like this. Of course, we'll replace both of the r's there. And now again, I'm just going to plug this in my calculator to see what I get. Now, if I'm thinking this correctly, I'm pretty sure what we're going to end up with is a domain error on my TI-30XS multi-view. Which if it gives me such a thing, then I know that we'd have an imaginary complex number answer, which they're not asking for on this problem. So we don't need the complex number or the imaginary solution as part of our solution set. So we just say, don't even worry about this one. All right, now my hunch was wrong. What I got here on the left, right? I forgot to put my question mark over the equal sign because we're checking here. But what I get in the end, and this is what my calculator is showing me directly, is it's not showing me the square root perfect exact answer. It's showing me the decimal answer. So this is what it shows on the left. It says you got -7. I'll put the whole decimal that my calculator put on the screen. And again, it's irrational because we have the square root of a non-perfect square right here. But again, this would say that -7.2 and some change value is going to be equal 0. And no, this one is false. Okay, and since it's false, we'd have to say this is not a solution to the original equation up here, because by replacing this r value into the original equation, it came out false. So we only have the one answer right there, which would make this true. Now here's a bonus for us. I said I'd come back to this and I'd show you a different way to do this. So let's go ahead and take a look at this up here in the top right. Now if I was to solve this, just like we've seen before, we would like the root on its own side of the equal sign. So to do this, we're going to need principles of equality. Now to do this for me, I'm going to need just a little bit more space there on the right. So here, let's go ahead and start on this. Now, like I said, I would like to isolate my square root of r. So if I square one side, I can just square the other side, which means first up, you can probably see that -4, we're going to have to zero that out. It doesn't even have an r. So if I add 4 to the left, I'm going to have to add 4 to the right, which is going to give me 4. And even right now, I can get rid of the r value as well by subtracting the r. The reason why I wanted more space right here is to show that the -r or the -1r right there is, it's not a like term with the 0, so I don't want to even make it look like I can combine those. And so here on the right, we get 4 minus r, and then we've zeroed out the r originally in black and also the -4, which means we can drop this -6 times the square root of r, and that will equal now 4 minus r. So this actually goes back to, I think it was one of our previous modules where we said, yeah, isolate your square root and solve from there. Remember, at this point, I would like to get rid of that square root. So what am I going to do? I'm going to square not just that term, but it's a principle of equality now. If I square one side, I need to square the other side. So it would have, in fact, let's go ahead and show this. It's be -6 square root of r times -6 times the square root of r. And so I see -6 times -6 is going to give me positive 36. And then we've got the square root of r times the square root of r, which is just a regular r, which is what we do want. Now, we have on the right side, we've got this 4 minus r, but it's squared. So we're going to have to take it and multiply it by itself. Now distribution and combining like terms, I'm going to skip a little bit there. Hopefully that's okay. But I get 16 minus 8 r's and then plus an r squared. So at this point, we can go ahead and let's go ahead and do this. I'm just going to rearrange this expression on the right. So I'm going to show it as r squared minus 8r. And then plus that 16 right there. And this, of course, still equals 36r. Now, at this point, I'd say let's go ahead and isolate the r's. Let's just make it equal to 0, right? We're looking at a quadratic and would like to make that equal to 0. So let's go ahead and do that. So I'm going to take that 36r and zero it out by subtracting it from itself. But yes, if I do it to one side, I need to make sure to do it to the other side. So this is going to give me 0, which is exactly what we were trying to do. I can drop my r squared. -8r minus 36r's is going to give me -44r's. And then this is going to drop my 16 right here. Now at this point, if you were trying to factor, you'd be in kind of a bad spot. What I'm going to look at here are my coefficients and then plug this into the quadratic formula once again. But of course, this is different than what we saw before. These two quadratic formulas right here with the plus and the minus were to solve for the u's. Now I can solve directly for the r's instead. So just for the sake of space, I'll still show the rest of that work and we can still compare our answers, but we're going to see we're going to get the same answer. So these two quadratic formulas here are to solve for r directly, because again, we have a different quadratic than we had over there using the substitution. But now that I have this, let's go ahead and go in here, and I've got my coefficient A is going to be the 1 right there. I already have B in a different color, but that's going to be negative 44, and then the C value there, again, is purple, so we're going to make that 16. So we're going to go in here and start replacing the numbers, the letters with the numbers. Okay, so I'm going to take the B's and the A's and the C's, and I'm going to replace them with their with the values that we have from that quadratic. Okay, now here's what we have for both of these, and if we went into the calculator, part of the problem is that by plugging these in, it's going to give us the decimals, because the discriminant here, the square root of b squared minus 4 times a times c, is going to be too big for my calculator to simplify. Now, if yours does it, that's fine, but mine doesn't, so I'm going to have to do this by hand. So I'm just going to do this one because as I evaluate the discriminant here, of course, it's going to be the same value in this discriminant here on the right with the plus sign. So first up, and again, I don't really need to do this by hand, especially with that negative 44 squared, but I can at least set up the rest of my problem. For example, I already know that negative 44 is going to give me 44 directly, and then of course we're going to have the minus with the fraction lines, and again I'm just working inside that square root, or I'm working with the radicand there, and then in the denominator we have 2 times 1, which is just going to be 2. But again, this part right here I'm going to put into my calculator, and when I do, I get 1872. Now I can take this exact expression and put it over here. The only difference, again, is that instead of that minus, we're going to have a plus instead. Now I can see 44 and 2 we're going to simplify to 22. And for those of you that remember the actual answer, there's a relationship there, but we've got to look at this 1872 and be able to simplify that. So I'm going to come up here, and I'm not so familiar with 1872. Okay, so I'm going to take that 1,872 and just look for some factorization that I can use. I kind of assume that it's divisible by 4, which I know is not prime, but I know the square root of 4 is going to give me a 2. So in my calculator, I'd say 1872 divided by 4, enter, and it says it's 468. Now, I believe I should be able to split up 468 as well by dividing it by 4. So I could say, well, that's also 4, and then it's the other factor there is 117. And 117, 1 plus 1 is 2, plus 7 is 9. So I know that's at least divisible by 3. Now again, why am I using 3? It's because it's a prime factor, and sure enough, the other factor, 39, is also divisible by 3, and that would be 3 and 13. Okay, so here's what I got. And you don't necessarily need these square roots, but I know the square root of 4 is going to be 2, and the square root of this 4 is going to be 2, and the square root of 3 times 3 is going to be 3. Whoops, I wrote that down as a 4. Okay, so these values right here, 2 times 3, are now going to be on the outside of that square root. So let's go ahead and come back down, and let's go and rewrite what we have now. So I've still got the plus sign, and it's still 44 plus that stuff all over 2. We are going to remain, or have a remaining square root there. Of course, that's that square root of 13 right here. So let's go and put that in the square root. But once again, I really have, on the outside of that square root, I've got 2 times 3, which is going to be 12. So I've got 44 plus 12 times the square root of 3. And of course, that means the other expression over here would be exactly the same, but with a minus sign instead. And then last of all, we can see the simplification that can occur. 44 is divisible by 2. 44 divided by 2 is 22. And then of course we'd have minus. And then we'd have 12 divided by 2, which is 6. And then we still have that square root of 13. Okay, so we have that one. On the right, we're going to have the exact same values, right? The 44 and 12 are both divisible by 2. The only difference is now it's going to be plus right there. So we have these two, and we've already checked both of these in the original equation. And of course, that's where we need to see the old work that we've already done. And over here, we saw that the minus 1 is not going to work. So we can just take that one, cross it out. We know that's not going to work, but we also know that the plus, the 22 plus 6 times the square root of 13 will work. And this is good. So again, this is two different ways to find the same exact answer. And I don't know necessarily which way you like best, but both work. Okay, now which one was easier? Again, you have to decide, not me, but this is one way to do this type of problem.